Alright, I think we're good to go here. We don't need Verilog or shift registers though. Cool, how is everyone?
Pretty good.
Alright, well this is the Faithful Four here. Alright, well, we have made it to the end of computer science at Clark. So congratulations. This is not an easy accomplishment. It's not only a very long sequence, it's a very difficult sequence, and it's a very sort of cumulative sequence. So much of what we do in these courses builds on what we've done in other courses. A lot of 222 builds on top of CSE215, for example, and 223 uses ideas from 222, and so on. So getting through all four of these CSE courses is not a small thing. And so congratulations. It's definitely a significant accomplishment. And on this side of the sequence, I think people are in good shape for what comes next if you're moving on to a university and continuing computer science. You should have a pretty good foothold for building into the kinds of courses you'll be doing next. And so the work you've put in and the time and the effort is hopefully, well worth all of that. So I had no new material to lecture on today. My plan was basically to talk a little bit about the exam and maybe do a once over on reviewing some of the subjects we've discussed, but mostly just to answer questions. I can show you some sample code for my version of NetDots if you think that might be helpful. We've only got 4 people in here, so we can kind of do whatever we want to do if there's something in particular that comes to mind. Otherwise, I'll just kind of go through what I just described.
I'm fairly interested in the NetDocs code. I want to know how you implemented the, I think it's like process click. Because I don't know whether it's because I didn't break apart my program correctly, but I ended up having to pass I think it's like the dots method, like object, to the thread, my thread object.
Yeah, that's okay.
Use the, like object dot process click, and then be able to pass it back into the object. It's like it was really honestly really jank solution to the problem.
Okay, yeah, we can take a look at what I did, but it can definitely feel like structurally a little bit spaghetti-ish sometimes, like we're passing a lot of information around, and this is partially a way to assess how you decided to break things into classes and where you decided to put certain behaviors, and sometimes kind of doing a post-mortem on that can help you envision different ways you might have structured things. For example, when the mouse is clicked, we need to send a message to the other player saying, hey, there was a mouse click. And there's different ways we could do that. We could do that from our mouse click code, and risk maybe hanging that up. Or we can do it from the net thread code, and then if the receiving side has gone away, the net thread will hang, but swing won't, right? And so we might choose to do it from a net thread. And we could do that by trying to access a method directly in the net thread, or we could try to, have something in the net thread that detects a mouse click happened and so on. And so lots of different ways to wire that. And like I say, after the fact, if you go back and you look at your code and you think, I kept, accessing this object from over here and using it, maybe I should have just put that object in this other class. Because I only access it once from the class that I put it in, maybe I should have used that, as an indirect reference and such. So there's not necessarily a right or a wrong or a better or a worse. It's all just kind of experience at this point. So let's see. I think I broke this into 4 classes. Wow, that's kind of extreme. I think my box class is minimal. So my box class is just, my 4 booleans, ownership flag, which is a character that's initialized to a space, um, and a reset method that clears out a box, which, presumably I call when I want to restart the game, and I call it in the constructor, which I didn't really have to do because, these values are defined up here. But that is what it is. So let's see what I've got here. So I wrote this a few years ago, so we'll see what we end up with. So I have my main frame, which is net.dot. My game is in a thing called a main panel. That's the my panel that we talked about in class. So I called it main panel here. Most of this code was generated automatically by Window Builder. The thing we've been calling net thread, well, I call that socket thread in here. So that's an object of type sock thread, and this is the socket through which I communicate with the other player. So boilerplate stuff. There's the main program. Here's the constructor for the main JFrame. So so I save my ID in a local object named mainframe. I don't think there's a reason to do that. But anyway, I construct a new JPanel. I call that game. And then here's the mouse listener code. We'll come back to that. There's the start connect button, and all of this is uninteresting. All right, so let's look at the startup stuff, and then we'll look at the mouse handling code. So there's a button called connect. And when it's clicked, I check to see if it's been changed into a quit button. So I had a button that could be either connect or start. If you're the server, it says start. If you're the client, it says connect. Once the game is running, it changes to quit. So how do I know what state I'm in? Well, I just check the text on that button. So I'm actually using the button as my state variable. And if the button says quit, it means the person hit the quit button. So I printed out a debug message saying we're exiting. I shut down the socket connection, and then I did an exit, which takes me out on my end. Otherwise, they hit either the start or the connect button. So check to see if you're the server. And so if you're the server and you haven't specified a name for the server, I set it to server. So that was this requirement of making the default server name server and the default client name is client. So I just do that by checking the current name. And then I reset the game and I show whose turn it is. So those are methods inside this game, which is the JPanel. And then change the button to a start button. If I'm the server,
Benjamin has a question.
Yeah, go ahead.
Yeah, I don't want to interrupt.
Oh no, go for it.
When I couldn't figure out for the net thread or for the PA5 was how were you able to exit out both of the programs when someone presses quit or quit?
So it's not a sick thread. So the the main loop of the net thread is this while there's another line coming in from the socketed connection. So when the other player wants to exit, well, they can exit their GUI by just calling system.exit. The way they tell me to exit is by sending a queue message, and that queue message gets picked up in here, and I go ahead and I do a system.exit right here. But if they don't quit politely, if they just, Control-C their program or X out the GUI, that networked connection will go away, and this has next line will come back false, and I'll come down here and exit my entire run method, and that will also shut this side down. But we only had to respond to the quit button, so when they hit the quit button, they'll send me a queue, system.exit on their end, and on my side, this system.exit will shut everything down on the other player's side.
Is there a difference between system exit 1 versus system exit 2?
Yeah, so the difference is that if I were to, from bash, print out the value of $? after this exits, this is the value I'll get back. So it's the status return for the program. And it's like in your main program in C, if you say return 0, return 1, same thing. It's the value you can get to from bash to see what the program exited. And I don't know why I returned 1 instead of 0, just to show that I'm not the one who quit, the other person did. All right, so let's see. Anything else in here that's worth mentioning? So game.save. So I have a text field named message that I can use to display information in this JFrame. I have a text field called score that I can use to display information. I have text fields player 1 and player 2 that store the name of these players. And I send those objects to my JPanel, my game, through this method called save. And game.save is just going to copy these arguments into local variables inside this game object, so that the game object, the JPanel, has access to the text field with a message, the text field with a score, the text field with the 2 player names. And let's see, I think we were up here at the net thread. Actually, I skipped over that. Yeah, so to start the net thread, I construct a socket thread, and I pass it the current JFrame, right? And I also pass it the JPanel. So that's mainframe and game. And I give it a tag saying, are you the server or are you the client? So depending on which I am, I call the same constructor in the same sock thread class, but I just give it a third argument to say, should you start a server socket or a plain socket? And then I go ahead and call the start method, which creates the thread and starts the run method. And then I pass that thread's identity to the JPanel. So I'm basically sharing all this information with everyone. So we've got our game. We've got our mainframe, and we've got our socket thread. So this is the JFrame. This is the JPanel, but extended so that I can, paint what I want. And this is the network thread. And I share all of this information. The mainframe knows how to get to these 2 things because the mainframe constructed these. But I also tell the game, hey, where's the socket thread, where's the mainframe? And I tell the socket thread, where's the mainframe in the game. So everybody has access to everything in here. And declare server, declare your identity. Oh, so this is just setting up the GUI. So so if I'm the server, I hide the host entry field, that field where you put in the IP address or the name of the host. I set the text on our main button to start. I make player 1's name editable, player 2 name's not editable, and I print a debug saying on the server. Otherwise, make the host entry visible, change the text button to connect. Player 2 can set their name, player 1 cannot. So that's just adjusting the GUI based on the radio buttons. And I think that's all there is in here. Oh, so the mouse click code. So when the mouse is clicked, first thing I do, I check to see if the current turn is the same as what my identity is. So game.player is an integer, I believe, that says am I player 1 or player 2. Game.turn is an integer saying is it player 1 or player 2's turn. So if those don't match, I print a debug saying not your turn and I return. So mouse clicks when it's not my turn are effectively ignored. Otherwise, I check to see if the game is running. If the game's not running, I ignore the mouse click. I'm not going to do anything until they hit the start button, which sets this running flag to true. Otherwise, take the argument, get the XY coordinates, call the click method in my game code, and then call the send click method in my thread. And so those are the two main things we want to dig into, this click method and the send click method. So, yeah, go ahead.
And where's the game code or the game click?
So that's in the main panel.
Okay.
So my click code, print a debug. If we're not running, I say click the start button to begin, but that won't happen because I don't actually call this. So that was left over from PA4. Find the row and column using this coordinate arithmetic that we went through. I print out the row and column as debugs. If it's outside of the number of rows or columns, print a message and return. But the effect to the player and the GUI is that, a click outside the legal area will just be ignored. Otherwise, I know my row and column are in bounds. Pick out the box. Find the distance to the left. So I used a modulo operator here, which is the same as doing an integer divide and then multiplying and subtracting. So how far am I from the left? If I subtract that from the box size, that tells me how far I am from the right. Here's the distance to the top, here's the distance to the bottom. Print those out as debugs, and then we have the long, horrifying if statements. If left is less than or equal to right, top and bottom, I'm going to take this as a left click. So if left is already true, hey, that spot is already taken, and this score field, that's a text field that I can write into. So I'll print up a message saying that spot's already taken. Otherwise, person clicked on the left side of the box. So set the box left to be true. If there's a column to the left, set that box's right field to also be true. Otherwise, if we click closest to the right, do the stuff on the right. Otherwise, if we click closest to the top, do the stuff on the top. Otherwise, we must have clicked closest to the bottom, so I don't have to actually do this if, so I'll just do the stuff on the bottom. So now we've updated our memory. We've updated the booleans in the box we clicked in and any neighboring box that should also be updated. So check the board. And this will return a value telling me if a box was completed in this turn. And how do we know that? Well, when we check the board, we look to see if there's a box that has all of the booleans true, but the character is still blank. And if it is, it means that box was just completed. So this tells me, did a box just get filled in? Update the score, which will go through and count the boxes and calculate the new scores. And if a box was not just filled in, change the turn. So if turn was 1, this will make it 2. If turn was 2, this will make it 1. So that's how we just switch between 1 and 2. Show whose turn it is, check to see if somebody won, and then call repaint to actually make all of this stuff visible. And that's the mouse click code.
Thanks. All your code looks really similar to mine, it's just in better places.
Okay, cool.
So I'm guessing you pass the game object to the thread object?
Yes.
Okay, and then you can just call the whatever click stuff from your socket.
Yeah, so the socket code will just go ahead and call this click code, and it'll do all of this stuff.
Okay, because I had my click click processing code in the main object.
Okay.
And to get it to run, I basically passed the socket object, the object of the main code that's calling it.
Mm-hmm. That's totally fine.
I think I did like send this.
Yeah, exactly.
And then I did like yes the. I think I called the object dots just in the other code, so it's easier for my brain.
Yeah.
Having like two parts of code saying net dots.
Mm-hmm.
One code says dots, and then it's like dots dot process click.
Right. Yeah. No, that's exactly the way to do it.
Yeah, because like it works. It just seems a smidge spaghetti.
Yeah.
When I could have done, because I think halfway through, when like most of my code was done, I was thinking like this probably belongs in the other thing.
Mm-hmm.
But I'm too far gone to fix it.
Right. Exactly. Yeah. So that's a totally reasonable experience. And you know, I wrote this version I think a couple of years ago, and if I were to rewrite this from scratch, it would probably look different. Because you know I've talked about this a few classes now, and in thinking about it and thinking about how to describe it and so on, you start to rethink how you would structure it and such. And so I would probably do some things differently also.
What do you think would be the biggest change you make to your code right here?
I think I would try to get a really clear idea of what needs to get used where.
Okay, so just better organization.
Better organization. So I think I don't know where all of my widgets are for like showing the score and showing whose turn it is and that kind of stuff. I think that's all in the J frame, and that's probably fine. But I think I would try to do all of those updates from one place.
Yeah, because I know that my code's just all over the place. I have my box code do some like slight one-off things, and most of it's just like getting in setting.
Yeah.
And then I also have like some like I think it just because of out of ease, I think my NetDots has like the most code in it because it was easier for me to think about. It can just handle it here.
Mm-hmm.
But there are some rather than trying to get the my frame stuff to handle some stuff.
Right.
My frame does obviously handle some like occasional things here and there. Most it's just like how do you if it's relating to like how the frame runs, then I have it run with the my frame stuff.
Okay. Yeah.
And if it's like what needs to be done when and like where,
Mm-hmm.
that will be handled by NetDots.
Right.
Handles thread things.
Mm-hmm. That makes sense.
That's why I basically put process click in
The frame.
NetDots rather
The
than
NetDots. Yeah. Yeah, that makes sense. Yeah, so I mean, if this is our J-frame, this is our panel where we're actually drawing the dots. This is the thread, which is kind of on its side. So we usually, we do our clicks in here, and our clicks need to communicate to the net thread. The net thread needs to get to our click code. The click code is going to run some methods which needs to update, these fields in the J frame, like what's the score, whose turn is it, and so on. I could put these things in the J panel, and I could modify my J panel code to offset the XY clicks based on where they are in here, and so on and so forth. So yeah.
I think I had it to where the process click was mostly just like, is this a quit? Or is this a click?
Mm-hmm.
And then pass those XYs to the actually I forgot exactly how it runs. It's a little spaghetti.
Okay.
But I'm trying to remember exactly. I think I give it the coordinates in context to the game frame.
Mm-hmm.
So that way 0, 0 is the top corner, and the other one's the bottom corner.
Okay. Yeah.
Let the game do that. I think I don't know. I need to double check my code.
Yeah, and I mean you could do this without a J panel at all. You could do this all inside just a J frame, and really make life tricky. But splitting it out does some of the work for you, like knowing if you're clicking in bounds and so on and so forth. So the rest of this is all just kind of like C style code, right? Is there a winner? We'll see if the scores add up to the number of boxes. My board is always square, so if the sum of the scores is equal to the square of the board size, the game is over. And once the game is over, if the scores are equal, I can say tie game. Otherwise, I can set the scores text field to either say, you know, player 1's name wins, or player 2's name, two's name wins. That's hard to say. And then I make the player names editable again. And checkboard, like we said, it basically goes through each box, initializes some score, and for each one, if the box is filled in and there's no name credited yet, we've got a new player, a new box that was just filled in. So I say new mark is true, and then I set the text based on whose turn it is to either player 1 or player 2's initial. Tally up the scores based on the text, the character inside the box, and then at the end just return this flag to say, did we fill in a new box or not? And then the thread is almost the easiest part of all of this. So the constructor, right, I save the parent, that's the J frame, I save the game, which is the J panel, and I save a tag to say, are we the client or the server, which is a string. So the shutdown method we looked at, if you call shutdown, it sends a queue, flushes it, and then just closes a socket connection. And then our main thread does one of two things depending on whether I'm the server or the client. So if I'm the server, make a server socket, wait for a connection, create the print writer scanner pair, send my name, get the name of the other player. So read one line from the socket, split it up in spaces, take off that second field, because I sent my names as n space followed by the name, and I use that as an argument to save other name in the J panel. And then on the client side, make a socket connected to whatever the text field is in that host entry box, port 1234, construct your print writer scanner pair, send the person my name, so read that text field, and then read one line, split it, take the second field, send that to game.saveOtherName. So lots of code reuse in here, right? This is the only thing that's different between the server and the client, is this chunk of code. And then show the game is running, show whose turn it is. I didn't really need to initialize these, but I think it avoided some compiler complaints. And then basically read a line from the socket, split it up into pieces. So my commands came in as either the letter Q, which we looked at, just go ahead and do an exit, or it's an X followed by an X coordinate, or it's a Y followed by a Y coordinate. So if it's X, set X equal to %. If it's a Y, set Y equal to %. And once I get the Y coordinate, I go ahead and I call click, and that does the mouse click code.
I had a question.
Mm-hmm.
So I got an error, like, you know how you send, like, initialize, like, some kind of IP address so that you tell, like, which machine you want to connect to?
Mm-hmm.
Have you figured out a way to handle it where if you send a invalid IP address, it'll just throw an exception, but then you get an error after that? So have you figured out a way to handle? Is there a way to handle that?
So if you're specifying an IP address, you're the client, right? Mm-hmm. And so here, you know, you're getting the IP address, that's the text field, and I'm constructing a socket. And I think you'll get an exception right here. So, you know, I could put, so right now this would say, you know, error getting stream, and my client would just exit. But, you know, I could put a try-catch block just around this statement, and my catch statement could say, you know, display a message that says, you know, invalid IP address, and then I just go back to business as usual. Right, so I could throw this inside some kind of while loop or something, depending on what you want to do. But if you've got all of this in a try-catch block, which you have to do for it to compile, if you put in a bad IP address, this will ultimately throw an exception, probably on this first line, and you'll come down here. And there's nothing the server has to do in that case, because it has no way of knowing that, you know, someone on the other side of the planet tried to connect to them and misspelled the name of the server, right? That's not the server's problem.
So you just kind of exit it right after you get the error?
Yeah, so I would just exit and make them rerun. But, you know, you could, like I say, put this in a loop. Throw this in a while loop that says, you know, while connection not established, or while not connection established. And if this succeeds, go ahead and set that flag to say connection established, and then it'll come back up here and kick out. But if anything goes wrong, it'll print an error message, go back up and try this again. But, you know, if it does that, that's gonna ping on here forever. So yeah, it's a little weird, because they've hit the start button. What you'd like to do is kind of like unhit that start button. So you could get really funky and you know, change that start button back to, you know, when they hit it, it should change to quit. Change it back to start, and just exit from here completely with a return, so that the thread goes away, and have your main program, you know, recreate the thread. But that gets arbitrarily complex pretty quickly. So, you know, if you're not specified within reason, you can set the problem to what you like. And so for me, I was just like, hey, if they put in a bad IP address, they're out of here. If they want to try again, they can rerun the client. And then send name just sends the letter N followed by the name you pass, and send click sends X followed by X coordinate, Y followed by Y coordinate, and flushes. So that was pretty much it. These things, some people have asked, these are inner classes. So these are classes that are created inside, in this case, the net.dot class, usually in that inner class structure of you know, like an event listener, a mouse handler, things like that.
So your question?
Yeah.
So on the exam, what are exactly going to be quizzed on in terms of PA4 and PA5? Because basically it's just taking previous program assignments and just giving it more applications.
So PA4 was a whole different thing from PA3, right?
Yeah.
PA4 was swing, basically. So being able to paint, right? So knowing where and how to paint, and calling methods, you know, from the graphics object, and also handling events, and kind of the whole shift to the mindset of event-driven versus procedural code. So writing code that, instead of looping and waiting for something, basically sets up a listener that will be called when an event happens, and then having everything happen in that listener. So those were some of the ideas in PA4. And PA5 was really, it was an extension of 4, but it was really a new assignment in terms of threads and networking. And so concepts in threads, what a thread is, constructing a thread, starting a thread, and things that we didn't have to get into as far as synchronization and deadlock and so on. And then all the stuff on the network side, so sockets, server sockets, client-server models, establishing a connection, IP addresses, port numbers, and then for us using print writers and scanners to write to or read from a socket. That was all sort of new material. So yeah, let's segue to the final exam, and see what we've got. Oh, SLPs. Let's talk about SLPs. So SLP presentations were yesterday, and nice job, everybody. So I actually got to visit some rooms this time, so Izad and I sort of coordinated things a little better, and it was pretty quiet in the main room after a while. So I got to hear some presentations, and that was really awesome. One thing I miss about the in-person expo is that it was 2 hours that I could spend walking around visiting different tables and listening to people talk about their projects, and that's really cool to be able to do because sometimes people started talking to me about their projects the year before they began the CS sequence. They might have seen an expo and thought hey, this thing we're doing in 250, that would be a cool project, and then to like see this developed quarter by quarter, and then see the final presentation of it is usually really really fun. And it's great to see the progress people make. So it was nice to be able to get to some talks yesterday. And it seems like visitors who came in really enjoyed it, thought there were some really good projects being done, and so on and so forth. So thank you everybody who showed up, and thank you for all the work on the SLPs. And I'm going to post an announcement later on, but I'll mention it here for the 5 of you that it's helpful in the future when students are beginning to work on their SLPs if they have some idea what people have done in the past. So previously, we've had the final posters that people would make hung up in the wall of the STEM building, and we can tell students, yeah, go down by the nerd cave and look at the posters in that hallway, and that'll give you an idea. So since we've moved online, one thing we've been doing is having students voluntarily make short videos, 2 to 5 minutes of their SLP presentation. And so I'll post an announcement with details of how you can do that if you like. It's a voluntary thing. You don't lose points for not doing it, but it's another way to share what you've done, talk about it a little bit, get some credit. If 10 years from now the thing that you did is the new Twitter, you've got video documentation that says, hey, I thought of that, but also it helps students when they're like, what's an SLP, or what kind of project should I do? They can like go to an archive and look at a video of you talking about your project and what the experience was like and what you learned and so on. So I'll post details of that as far as what I need and what has to be included in the video. But I just wanted to mention that. Any comments or thoughts from the presentation yesterday, or from the SLP overall?
I think, did you close the room at 4:45?
Oh, oops. Yeah. So it was dying down, and we had Izad sent a message to the room saying, hey, the visitors are done going through. You're welcome to leave. Thank you for presenting, and so on. And there were still a few rooms that had some people in there. I think we had one visitor in a room. And I told Izad, I'm happy to stick around until 5. And he's like, okay, I'm going to go take care of something. He made me a co-host, and he exited Zoom, but instead of transferring the hosting over to me, it just closed out the whole session.
Okay.
So
Because I was in the middle, because we got that, our group got that notification while we're doing one last final.
yeah.
And I think I got just to the end of my presentation. It was the questions.
Okay.
And luckily, I was the last one in the loop. But I forgot to get to the questions part.
Oh, okay. Yeah, sorry about that.
Whoa. And I checked to say, is the room back up? No, it's not back up.
Yeah, I opened it up as quickly as I could afterwards. Well, I couldn't open it up. I tried to open it up, and then Izad came by and opened it, I think. So yeah, everyone got kicked out at that point.
Jack, just to be clear, did you ask if anyone had any questions a few seconds before it shut down?
Okay.
I don't know whether the questions part actually went through.
Okay.
Because I didn't go. I tried it, and after 2 minutes, I'm like, I think the room's closed, and then I just went off to do something else, go to study.
Okay.
So that one visitor did not have a chance to ask questions.
Okay.
Oh, I know.
Yeah, that was an oops on the part of Izad and myself, but yeah.
That was hilarious. I think I left around 4 o'clock.
Okay.
And I had to repeat my presentation like three or four times because people kept coming in and going on. And
I think you'd done it 3 times before I even got there.
yeah, I know. I had to I wish I had like a script instead of having to memorize it in my head.
Sometimes it's nice though to like do the same presentation because you sometimes discover new things. Sometimes you think you understand a project, but when you start trying to explain it, especially if you're getting questions, sometimes it restructures it in your mind. And reading from a script gets really boring really quickly, at least in my experience.
Or you get very lazy and just kind of think of a good summary of what I said earlier.
Yeah, yeah.
Because I think the first time I went too much detail, so like like my third attempt, I kind of went a little. I didn't explain too much what my code did, rather than just kind of a little summary of like what I made.
Mm-hmm. Right, right. But yeah, your demo looked cool. Oh, that's too bad. Yeah,
At least we got a visit though.
yeah, well that's good, and I got to hear it, so that's good too. um, when you're working on research areas, like if you're at a company that's doing research or you're trying to get funding for a project, sometimes you'll go to conferences and present papers on what you've been doing to try to stir up interest in it. And a lot of conferences have sort of 2 versions of this. There's usually presentations of papers where you'll go up on a stage at a podium in front of a ballroom filled with people, and you'll present a talk similar to what you were doing yesterday, and then at the end there's a few minutes for questions and so on, and the questions are always the fun part, right? The talk is kind of like you're doing your thing and you've probably rehearsed it. I used to rehearse about 40 hours for a 1-hour talk. It was about a 40-to-1 ratio. I don't do that anymore, but when I was first doing talks, so you've really got your talk down, right? But then the questions come and it's like stuff you've never thought of before, and that's where it gets really fun, in a good way. But the other thing that a lot of these conferences do is what are called poster sessions. I think we've talked about this around the SLP. Poster session is more like the in-person version of what we did yesterday, where you basically have a ballroom filled with people and tables and posters displaying a synopsis of their work, and visitors just kind of walk around from poster to poster and read it, and if they're intrigued they might talk to you or introduce themselves and have a conversation and so on. And that's all question and answer stuff, and that can be fun too. And sometimes I think my most severe experience of this type was I spent about 60 hours, 80 hours maybe, preparing a talk, practicing a talk, working out the timing, a bunch of time, writing the paper and submitting it and revisions and all this to get invited to a conference in Boston. I was living in Virginia at the time, and drove to Boston, and was in a hotel, money, and all this sort of stuff. And I got to the room where I was going to do my talk, and there were like 5 people in the audience. And there were a total of 6 speakers that day. So the 5 people in the audience were the other 5 speakers, plus myself was number 6, and that was it. And it was a significant chunk of my life that had gone into this thing that was, I guess kind of like room 9 yesterday. It happens sometimes, and that was my choice. Nobody forced me to do that. I maybe could have, checked ahead of time to see how many people go to these things and so on. On the other hand, there was a big get-together later on where I got to meet a bunch of cool people from other sessions and make some good connections like that. So these things can be hit and miss sometimes. in university, you'll work on a capstone project, usually your senior year, and that will be a very different experience because there will be a lot of attention paid to that, often in the forms of weekly status updates, weekly meetings, weekly get-togethers with the sponsor, and that can feel like a very different experience from the SLP. That can end up being very heavily micromanaged and very high stakes. I mean, it's an entire course that's worth, your whole grade is how you do on this project, and if you don't pass that, you don't graduate. So it's a very different thing from the SLP, but a lot more structure and in some ways a lot more reward. Any other thoughts, comments on yesterday's presentation or the whole SLP process?
I just wish I had thought of switching to swings. Yeah.
Ah, okay.
Because then maybe I would have been able to do something more about it.
Mm-hmm. I think a good project, you're always going to look back and think you could have done more, though. A project that you like completely finish in the first month and then there's nothing to do on it after that, probably means you could have set the bar higher, and I don't think it's bad to like finish thinking like, oh, I could have done these other things, or I should have changed direction or something like that. That's good learning. Let me ask a general question, because this is something I've gone back and forth on. How would people have felt if back when we first started talking about SLPs, if you had been assigned a topic instead of being told to pick a topic yourself? What's your impression of what that experience would have been like? Would that be like easier, harder, unpleasant, welcomed?
So I've been at Clark for about 3 years, so I've done this SLP thing twice.
Mm-hmm.
First time around, I would probably preferred it because because like partway through, because I got my idea. The first time around, I think I had like an anti-sleep alarm, where basically it's like it would wake you up if you fell asleep. And like partway through, I kind of because I got this suggestion from like a friend, and partway through, I just kind of like lost my passion for it. I'm just like, there's a better thing I want to do.
Okay.
And so, like, while I'll probably still like not have as like strong of a passion for it, I'd at least have more of a reason to do it than because it's like it might just be the fact that I have ADHD, so I'm just like, ooh, I have like 50 half finished projects,
Mm-hmm. Right.
25 full finished projects. So if I had like here's your topic, then that would be a reason to continue that direction, rather than using my own will to be like, I'm going to continue this project.
Right.
Partway through, I just didn't have I didn't have the same kind of like drive as this first argument. So I think it would be an improvement. This time around, I'd probably be I'd just be neutral about it, because I sent you the email. I switched to my drone project because I wanted to more consolidate my schedule. But so I think depending on the scale of the SLP you assigned would depend on how annoyed I would be.
Right.
Just because I selected mine because I wanted to better consolidate my schedule.
Mm-hmm. That makes sense.
I don't think it's a horrible idea, but I think I could see reasons for both. I think both are like equally fine.
Mm-hmm. Cool.
Or just do both if you want to like choose your own topic, but also here's some suggestions that I would say you should work on.
Yeah, so I've did that when I first started teaching this stuff. I had ideas and or come up with something on your own, and almost everybody chose to come up with something on their own. So that's interesting. And somebody else said in chat that if you let students pick their own topic, lets them find out what their passions are, and that's definitely true. And that's my ideal for the SLP, is it's something that's like, something you really want to be doing, something you're thinking about when you're in other classes, and you're trying to do some, Econ 202 or something, and instead you're like thinking about your Android app or your Arduino project or something. Yeah, so more structure or guidance, that might be the good middle spot. Let people pick their own projects, but make it a little less open-ended. And maybe example projects, even if they don't end up choosing one of the examples, maybe it helps guide the kinds of things that they can work on.
I think
And
I kind of, sorry.
no, go ahead.
So I think I kind of lost my passions. I used to have a lot of passion for my project early on, but then after kind of digging deeper into like the coding and the amount of work that I need to do and seeing how other people do it, because so I kind of realized that because the amount of work I have to do is a lot of, I have to have an insane amount of passion in order to actually be able to get a fully working prototype,
Mm-hmm.
or maybe have more people with different experiences work on a team to try to create a really good project.
Right, right.
I kind of wish I had more people on my side, but
Yeah, well, you had a group member that disappeared, right?
yeah, which is a bummer.
So
Like,
that's a big change.
I think for future reference, there's got to be a way to maybe create some project where it's doable by yourself. Because I was going way over the top of like, I want to create like a full working project of like an actual program that would, a really powerful program rather. But because somebody else disappeared, or maybe they just didn't want to go to computer science, it put more weight on my shoulders where I have to kind of sacrifice a lot of goals
Mm-hmm.
in order to not put too much work on my arms.
Right, right. Yeah. I got to tell you though, so this was an open CV project, and after you showed me some of the work that you had done so far, that got into my brain, and that became one of my passions for a few days, and I lost a bunch of time that I should have been like grading lab reports, I think, playing around with OpenCV and trying to get it to run on a Raspberry Pi. And that was a lot of troubleshooting and trial and error and lots of things that like this should work but it doesn't because of such and such, and that took me down a really fun rabbit hole for a number of days. And I finally did get it running on a Raspberry Pi, and it turned out to be a little too slow for what I wanted to do. But that was fun.
You know which type of Raspberry Pi you're using?
Raspberry Pi 4.
Oh, okay. I was just like, oh man, you could have like if it was like trying on a 0, then maybe a 4 would work. But nope, nope.
No, this is a nice beefy one, and it had all kinds of glitches, and you can't use the latest version of this, but you have to use the latest version of that, and so on. But finally got it to work. But it runs fine for a few seconds, and then it'll lag for like half a second, and then it goes back.
I think it's because, I mean, for me, I know from personal experience that Python can be kind of slow, especially when I first run it, every time I press run, it would take about 10 to 15 seconds for it to actually display.
Yeah.
So, I don't know if that's just a Python thing, or if that's just maybe like I could have made the algorithm that I used wasn't very fast. But, yeah, I know there's a way you can make it in C++, but
Yeah.
I don't want to go down that route.
Right.
University.
Yeah. Yeah, there's definitely some kind of big startup overhead, and my plan was just to keep it running, and just pay that startup once, but a little laggy here and there. But if you really want to do like real time computer vision, you can get like a Jetson Nano or something, and that's a whole different ballpark. But it was fun to play with, and I've known about OpenCV for years, but never actually dug into it. So that gave me an opportunity to actually like go through some tutorials and get into it. So thank you for that. And these projects are supposed to be learning experiences. They're supposed to start in an area that you're interested in, and find some stuff that you want to pursue and dig into it. and then, this is good stuff down the road. Maybe, if you have a good experience with that and you get to a university and there's a course, in machine learning, and it's, time to come up with a project, you could take some computer vision and tie it in with some machine learning and do something like that, or an embedded system class or whatever. So that's all good stuff. All right. Well, let's take a short break, and then let's come back and just talk about logistics on the final and topics and how to prepare and stuff like that. So let's come back at a little over 5 minutes. All right. So I'll see you back in a few. All right, we're back. So yeah, let's talk about the final exam. And I'm going to post an announcement to remind people of this, but let me mention it here. Make sure you're logged into Zoom during the final exam. Occasionally, there's some kind of typo or inconsistency or incompleteness in a question, and as soon as somebody tells me that, I'll announce a clarification or correction in Zoom. And if you're not in Zoom, you have no way of knowing that. So hop into Zoom, just so I can announce clarifications and such. So final exam is yeah, hopefully there's no typos, but we usually catch them pretty quickly. But hopefully not. So final exam will be Monday. It's during the regular class time, so it starts at 10 o'clock. The regular time allowance is an hour and 50 minutes. Same drill as always. So there'll be a PDF of the exam. You can download that or look at it on Canvas, write up your answers, upload them as a PDF before the deadline. Closed book, closed notes, no resources other than your notes, which are 6 double-sided, 12 single-sided pages, any format, any reasonable size, and so on. So exactly the same setup as the midterm, except the exam is an hour and 50 minutes instead of 50 minutes. It will stay open beyond 11:50 for people who have an extended time allowance, but if you turn it in late, it's 10 points per minute. So don't turn it in late. That's the easiest strategy. And so I haven't looked at this. This is from last year, but let's go through this and we'll edit it as needed. And add and remove and so on, but just kind of quick once over of what we've been doing all quarter. So writing code, analyzing code, answering questions about code, right? That's the usual expected exam experience. You'll have some coding questions. You may have some short answer, fill in the blank, true, false, write a couple of sentence type questions. I decided what I would really like to do, but I'm not going to do it, was make this whole thing an essay exam. I might do that next year. I'm not going to pull that out of the hat at this point in the quarter, though. So I will not ask you to write essays.
I'm so glad I actually I wrote to college earlier than later.
Yeah.
Otherwise, I don't like writing essays, but
Yeah, but it is so much easier because there's times when I look at someone's code and I really don't know what's going on, and then if they come and they talk to me, it makes so much more sense, and I can say like, oh, yeah, I get what you're trying to do. Here's the one thing that's different, and so I actually learned to really like essay questions, because if someone says, tell me what you know about classes and objects, I can go on and on and on, and there'll be some truth in there. But if someone gives me a particular statement, I don't remember what extends means or something. But anyway, I'm not going to do that now. But you might see short answer, 1 or 2 sentences, right? So that's your general write code, analyze code, answer questions about code. Maybe here's some code, make some changes to it, that kind of thing. So Java, object-oriented language, you should have a pretty good feel for what we mean by object-oriented now. The idea of an object, an instance of a class which bundles code and data together. I'm doing my Darth Vader hand movement now. Bundles objects, bundles code and data together. So we have code that manipulates certain types of information. That information gets put together with the code that uses it. Java is interpreted, right? When we compile it with Java-C, we get bytecode, and bytecode is this machine code for an artificial machine called a Java virtual machine. And that's the thing that's actually executing the code in the class file. As opposed to C, which compiles down into whatever the actual underlying hardware ingests. So if you're on an Intel processor, it's x86 code. If you're on a Raspberry Pi, it's ARM code, and so on and so forth.
How's bytecode different from native machine code?
Bytecode is native machine code for this machine, the Java Virtual Machine.
It's a different name, I suppose.
Well, so when you compile a C program on a laptop, it compiles into x86 machine code. When you compile on a PIC processor, it compiles into PIC machine code. When you compile Java code, it compiles into JVM machine code. But what the heck is a JVM? My laptop does not have a JVM processor. It has an Intel processor. So there's a program running on my laptop that thinks it's a JVM, and it interprets this machine code. So it's a virtual machine in that sense. And so this bytecode it compiles into is this machine code of this virtual system called a Java Virtual Machine.
I think that's the reason why that Java has advertised themselves to be the right one and run anywhere, because you can download the virtual machine to interpret it to code, I suppose.
Yep, you got it. So it makes it super portable, because as long as you can port the JVM to a different system, you can run your Java code on that system. So you've got a smartwatch and it has a JVM on it, you can run your Java code. You can run NetDots on your watch. So that's pretty cool. So that makes it portable. So object-oriented approach, bundling of code, which we call methods, and data, which is variables, into an object, which is an instance of a class. And so that's encapsulation, right? Bundling this code and data together. And then there's information hiding, which is giving the user access to certain pieces of your data structure and hiding other pieces from them. And that combination gives us the notion of an abstract data type. So a linked list versus, a PA2 linked list from CSE222 at Clark College, right? That's a particular implementation of a linked list. But a linked list is the same here as it is at MIT, as it is at UW, as it is at, Edinburgh University. A linked list is a linked list. It's got, a collection of data. You can insert things and remove things and so on and so forth. But the implementation can vary from one implementation to another. So abstract data type is, what is the actual data type? What is a linked list? What is a hash table? What is a stack or a queue? All right. Definitely know, general Java syntax. You've been writing this all quarter. So if statements, fors, defining variables, declaring them, giving them values. All of that stuff should be second nature at this point. The newer stuff, if you haven't done objects before, is the notion of classes. So you can define a class, with the keyword class space, blah, curly bracket makes a class named blah. And inside that you can write methods, which are functions, and you can define fields, which we sometimes call properties. And then you can create an instance of that class using the new keyword. So if I say, blah x equals new blah, that creates an instance of the class blah, and that instance is called x.
I thought X was considered an object of that class.
Yeah, x is an object, which is an instance of that class.
Okay.
Yeah, so objects are instances. And then if you have an object and you want to access a variable in it, you could say, object name dot, the name of some field. Or you could run a method by saying object name dot, the name of the method, with parentheses and possibly an argument list. There's the signature of a method, which is the combination of the name and the argument list. And so a function named, main that takes an argument that's an int is different from a function named main that takes an argument of 2 ints, or an argument of a string, or an argument of 3 strings, an integer, and a double. Those are all different methods because they have different signatures. Static versus non-static. So most of what we've been doing has been non-static methods, or what we call instance methods. So when you write the area method in the rectangle class, that's an instance method. We don't pass the area method the height and width of the rectangle. we're saying, you know, name of a rectangle object like r dot area, and that area method is being run on behalf of that particular instance of a rectangle. A static method runs without having a particular object. It's run from the class directly. And so something like math.squareRoot, right? We don't have to construct a math object. We can just say the name of the class math.squareRoot, and it just runs a set of code that happens to be in the math class. So static methods and static fields can be used by just specifying the name of the class, whereas instance methods, which are non-static, are accessed based on an object. So static, we can think of that as a class versus non-static. Which is an instance method. And since methods have signatures, constructors also have signatures, and so we can have constructors. The name of the constructor is always the same as the name of the class, but the argument list can change. So we can have a constructor with no arguments, an integer, a string, a double, 2 strings and a double, 15 integers, 2 strings, 3 doubles, and a float. These are all different constructors. And when you call a constructor, the system looks to see what types of arguments you're passing to decide which constructor do you want to call. Same thing with methods. Alright, as far as data structures, you should know how to do arrays. So, you know, int bracket bracket, name of array, equals new int bracket, however many integers you want. So arrays are basic data structures. Lists, as in linked lists. And, you know, we did a lot of linked lists in 222, so we talked about, you know, doubly linked lists and circular lists and sentinel nodes and all that kind of stuff. We didn't really get into a lot of those details in here, right, but they're still important. But we also talked about the linked list class, which takes care of a lot of this stuff for us. Trees, so we did a PA with decision trees, and in 222 we did a lot of work with binary search trees, and looking at, you know, height and balance and depth and all this kind of stuff. So all of that stuff is relevant. Recursion comes in a lot. A lot of the algorithms we work with are recursive in nature, particularly with trees, but possibly with some other stuff. And so we should be pretty comfortable with recursion at this point. Generics come in when we start using classes for things like, you know, data structures like linked lists or hash maps or stacks or queues, where the behavior of the code is basically the same regardless of what type of data we're using. So a linked list of strings, a linked list of ints, a linked list of doubles, the code is almost exactly the same. Really, the only thing that changes is, you know, the data field of a node goes from a string to an int to a double. So we can define a class to have generic arguments, and we can force the person who uses this class to specify what kind of object or objects do you want to use in your data structure. So a hash map, for example, is driven by a pair of items, a key, and a value. And so when we do a hash map, we specify inside angle brackets the type of object that a key will be and the type of object that a value will be. So if we want a hash that uses strings to access doubles, right, we could say hash map angle bracket string comma double. Or if we want rectangles that are used to access NetDoc games, right, we could construct a hash map whose keys are rectangles and whose values are NetDoc games. And we would just say hash map angle bracket rect comma NetDot. And now, you know, we've got a really weird hash table. You can put in a 3x5 rectangle and access a NetDot game off of that, whatever the heck that would mean. And so a generic, right, lets us specify these parameters and then use these inside the description of the class to fill in particular types of data. We talked a little about iterators. We've been using these without necessarily talking about them a lot, but when we do something like has next, well, something that has next, and then we use a next method. This is a way to iterate or to move through a collection of data. And we typically have been using this when we play with scanners. So we say, well, the scanner has a next line, let's read the next line and do something. But that's a particular version of a more general concept, which is, suppose you have a pile of data with no inherent organization to it, right? This is what happens with a hash. What we'd like to do is be able to access all the data in here in no particular order. We can use the same kind of structure. We can say, wow, there's another piece of data available in here, get that next piece of data, and then we can do something with it, print it, analyze it, compute it, whatever. And so this is the notion of an iterator. And we can construct an iterator on this data, and then we get a has next and a next method. We have not done enough of that in code for me to ask you to write code to do that, but I could still find some ways to bring that up, I suspect. But it's something you'll use a lot in the future. So, strings. You should know some of the basic stuff that we do on strings. You should know the length method to see if how many characters are in the string. Equals to compare to strings. Compare to if you want to sort strings. Character at to get the nth character. ToString, which works for every possible object and returns a string version of that object. And one thing we do a lot is we write our own version of ToString to say, hey, if somebody tries to take my NetDot and turn it into a string, what would I like that to do? Well, maybe I want it to return, the size of the board and return a string like, an 8x8 dots game. So I could write a ToString method inside NetDot, and then if somebody constructed a NetDot and tried to print it, it would, print out something reasonable. And then, this idea of double equal sign versus like an equals method. Equals compares character by character. Double equal checks to see if two objects are the same. If you like, it's kind of like comparing memory addresses on strings in C. And so sometimes this will look like it's doing the right thing, but it's not. It might just luck into doing the same result as the correct thing. Alright, so defining an array, we talked about that. Setting the length of an array, so that declares data to be an array of rectangles. But if I try to say data bracket 0, I'm going to get an error. Right? I've declared this, but I haven't given it an actual value. I haven't constructed it. And so I need to say something like data equals new rect bracket 10. And then if I want to actually do something with like data bracket 0, I have to construct that actual rectangle. This is setting up the array, but the elements of that array are still null. So this is an array of 10 null rectangles. Now if I say data bracket 0 equals new rectangle 3, 5, that's actually a rectangle. But if I don't do this and I say, data equals new rectangle bracket 10, let's print out the value of data bracket 0 dot area, I'll get a null pointer exception. So when we construct an array of integers, I can just do this. And that's like, integer x bracket 10. That gives me my array of 10 integers and they're ready to use. I can say x bracket 0 right away and no problem. That's because this is a primitive. When I construct an array of objects, I have to do two things. First, I have to actually make the array itself, and then I have to construct each of the things in those array. So that's that slightly weird two-step piece to creating an array of objects. So this is initializing the array versus initializing the objects in the array. And then just remember, if you want to know how big an array is, there's a length field. And so I could say something like, data dot length. And it's not a method, it's just a field. And this would return, in this case, the number 10, telling me, hey, there's 10 things in that array. All right, scanners and print writers. We used these before. We use them again with networking. So scanners are for input, print writers are for output. For future reference, these are not the only ways. These are probably not the best ways to do input and output, but they're easy ways in that, they always work the same, whether we're going from standard in, standard out, or from a file or from a socket. They always work for us. So we can read from system.in. To read from standard in, we can use system.out to do output to standard out. So when we say system.out.println, we're doing something like what we do with a print writer, where we construct a print writer and we say that print writer object.println. It's an output system. So for reading in, we can use has next or has next line paired with next or next line to actually read from the input stream. And when we do a print writer on something other than standard out, we probably want to call flush because our output is usually buffered. And if we don't print a new line at the end and we print a standard out and we want that output to appear and we're not going to read from standard in with a scanner, we want to go ahead and do flush also. So there's this notion of buffered I/O, that when we write something to standard out, it doesn't go immediately to standard out. It goes into a holding area, and that holding area eventually gets pushed to standard out. We can force that push to happen by calling flush. For inputting, we wanted to construct a scanner. You have to construct a scanner with an argument of new file, where the argument to the file constructor is the name of the file you want to read from, name and path. Print writers, we can construct a print writer with just the name of a file, and it will create that file if it doesn't exist, and then write into that file. So somewhere around here was the midway part of the course and the midterm, and then the post-midterm stuff starts somewhere around here. So class extensions, we use these extensively with things like swing. So when you wrote netdot, it was actually an extension of a J-frame. You may not have actually written that if you were in Eclipse and you said, new other J-frame, and you called it netdot. Window Builder wrote some code for you saying, hey, this is a class called netdot and it extends J-frame. But you probably explicitly used the extend keyword when you made your panel. So if you said, class game panel extends JPanel, right? You're doing a class extension. And you're saying, hey, this JPanel does everything that my game panel does, but I'm adding some extra stuff or changing some stuff in my game panel. And so if our game panel is extending JPanel, we can use the super keyword to get to stuff inside the original JPanel. And we do this mainly for the paint method. We'll talk about painting in a minute. But if we want to call the original class's paint method, we can say super.paint. But we can also, add new methods to our extended class, or we can override methods from the base class. Let's see. Exceptions and exception handling, so try-catch blocks. We didn't talk a lot about otherwise, but otherwise is this kind of catch-all block. Mostly we need to know about try and catch. And important point here, keep your try blocks small, right? I'll usually remind you on an exam question, but we put try statements around the part that might throw an exception. And if you're able to detect that exception reasonably, do that. Don't just wait for a try block, because try blocks are expensive. They take a lot of code. They take a lot of time under the hood. So, if somebody wants to read the nth element of an array, don't just do it in a try block to see if it goes out of bounds. Compare n to array.length, right? It's one if statement. And if, n is bigger than or equal to array.length, then print a message saying like, hey fool, that's not a valid element, right? So use try blocks when you can't reasonably tell if an error is going to happen. For example, you're trying to open a file for reading. You could, construct a file and check the permission bits and check the ownership and check who's the owner, who's running the code, and all that stuff. That's a lot of work. In this case, it's easier to just say, hey, let's just do this in the try block. And in the catch block, we'll say couldn't open the file. But if you can check for something, with a couple of lines of Java, do that. Try blocks are like the sort of last chance effort for, I think this will work, but maybe it won't. So let's put in a try catch. All right, swing. I am not going to ask you to write from your head or from memory things like mouse listeners, or to know all the properties of a J-frame or things like that. We've been using Window Builder. I've been encouraging people to use Window Builder, which writes a lot of code for us. So the code that Window Builder makes for us, we don't need to be able to write that ourselves. We should be able to understand it, other than maybe the inner class stuff, because that's weird and takes getting used to. But the idea that, when I go in Window Builder and I drag the corner of my panel to make it 400 by 500, there's a piece of code in there that says set size 400, 500. That should not be totally mysterious to me, right? Set size is a method that's available in the current class, which is, in this case, a JPanel, and it sets the size of the current panel.
So you're saying you might give us like some code from PA4 or PA5 or something like that, and then we just kind of analyze and answer back what it does?
Yeah, so I could give you some code like what Window Builder might produce, and say, go ahead and add something to this, or change something here, or I might give you some code and ask you some questions about it. But I'm not going to say, go ahead and write a tic-tac-toe game, because we wouldn't do that anyway. We'd use a tool to tell us what classes we need and what to import and set up the handlers and all that kind of stuff.
I was going to make a little joke saying, it doesn't make it a code game. You can make it a code game before the exam, and then just write the call method inside the exam.
Yeah. So we've been playing with swing. We've been making GUIs. So one of the main things that we have to do, and you definitely want to know about this, is this business of painting. So in swing, painting happens inside a paint method, and we don't get to call the paint method because paint gets called with a graphics object, and it gets called at a time that is appropriate for it to be called. So for example, when the display is being refreshed and we're halfway through a refresh, we don't want to repaint the panel at that time. Or if something else is making changes to it, we don't want to repaint in the middle of that. So paint gets called at an appropriate time, which means if we want to display a rectangle on the screen, we can't just say draw a rectangle. We have to set something up in memory. We put a little note in memory saying, hey, I want to draw a rectangle. and we change paint so that when paint runs, it looks at that little note and says, oh, I'm supposed to draw a rectangle. Okay, boom, there you go. So we do two things. We override the paint method in our class to do our stuff, and usually to call the superclass's paint method, so we'll say super.paint in the beginning. And we write this method to do the things we want to do based on values that we've set up in memory.
I forgot. So super paint just gets the original paint from the extended class.
Exactly.
Do you just copy paint into that, or I forgot how to set it up?
So you said it almost perfectly. So if I do class my panel, extends JPanel. Alright, so down here is public void paint. Takes a graphics argument. So if I say super.paint and I pass it that graphics object, it calls the paint method from the original JPanel class, which means it will paint the JPanel. It will draw the border, it will add the highlighting if I've got highlighting or shadows, it will draw the components that are on there like buttons and so on and so forth. It'll do all the stuff that I want to have done. And then I can do things like, draw boxes. I can add my own code in here to say, hey, let's draw a set of dots. Let's draw lines between these dots based on these booleans and so on and so forth. And then somewhere down the road, something will call whatever the my panel is, game board or something. We'll call that thing's paint method. This is the stuff that'll happen. This will draw the JPanel itself, and then this will do whatever other drawing I want. And so it's usually that pair of operations. It's extending a class and overriding the paint method. And it's this idea of deferred painting. When someone clicks the mouse, you don't say draw a line. You say let's set this boolean to be true. And then you call repaint, which calls the paint method, which looks at the booleans and draws lines. So it's this one level of indirection, and this is common to a lot of these systems. By the way, the Android thing that I did on Monday, when we started off, I was having problems, and we took a break. And during that break, I rolled back to a previous project I'd already done the night before, and we used that. But Monday night I dug into it further and I figured out what the problem was. And the problem was that between Sunday night and Monday morning, something had updated somewhere in the universe, and there was a version number in one of the build files when I created a new project that was incompatible with something else somewhere, and it took me about 3 hours to find that. And so in Tuesday's Android demo, I showed the steps that I used to undo that version update, and it was a really excellent example of kind of how annoying some of these things can be, and how fragile they can be, and how simple they can be to fix once you know what the fix is. But this is just kind of like this moving target business that I alluded to, but it was moving a lot quicker than I anticipated between Sunday night and Monday morning. So if you're curious how to actually start an Android project, Tuesday's Android lecture went through that. But this was just for my version, my system, my version of the studio software and so on. If you download fresh, there's a good chance it'll work right out of the box. But that made me think of that. Alright, so event handlers, mouse handlers, button handlers, and so on. So this is the idea of event-driven code, and this was something that was sort of unique to Swing compared to C or Bash. So the idea of we don't make a while loop and say, while button is not pressed, and wait for the button to be pressed. Instead, we register a listener, and we say, hey, when the button's pressed, call this code. When the mouse moves, call this code. and somewhere in the mind of Swing/Java/whatever, there's something which is responding to button presses and mouse events, and part of that response is, okay, let me find everybody who wants to be told about this event, let me call their code. And so if we register a mouse listener and somebody presses the mouse button, eventually the code that we registered will get called. And in the case of a mouse button, it'll get called with the XY coordinates of the mouse click, as well as information about what button was clicked, were there keys being held while the button was clicked, was it a long click or a short click, and so on. And so PA4, PA5, we switched over to this idea of event-driven code, and again, setting things up for later, and then responding when things happen. And this is similar to the paint method, where we set something up and then eventually it gets used to paint. Yeah, go ahead.
So you expect us to, or not expect you, are we expected to write event handlers or mouse listener code, or is that already given to us?
So I don't expect you to know, what the name of an action listener is, or what the arguments to it are, or things like that. We've never even talked about that. We've looked at it a little. So again, I might give you a piece of code like what would happen when you say add event handler, and I'd put some comments in there saying like, add your mouse handling code here, and you'd be inside a method with an argument, coming in and that kind of thing. So probably nothing different in spirit from what you've done in PA4 or PA5. Maybe different particulars. Or I could ask you, conceptual questions about this. Or the 20-page essay question, right? All right. So yeah, basic concepts there. So threads, threads are separate execution contexts. It's a way to basically run two methods simultaneously, two or more. And the main way that we talked about creating threads was by extending the thread class. So class, netThread extends thread. And when you do that, you have to write a method named run. And this contains the things that you want your thread to do. So it's like the main program of your thread, but it's called run. It's public void, takes no arguments. And when somebody wants to start a thread, they call the thread start method. They don't call run, even though that's the main program. They call start, and start does two things. First, it creates a new thread, and then it calls run, the main method. So you extend the thread class, you make run method to be your main program, and then something else can construct the thread called start. That creates a second thread and calls the run method. And then you've got two things running simultaneously.
So, another question. So if it extends thread, is there anywhere where I could use the super, use like super dot, whatever the thread class, whatever thread method I can use?
Not terribly often. So I don't know what methods are available in the thread other than start, which we're not going to override. Run is usually the only main method that we override, and the run method that we inherit doesn't do anything. I think it just returns. So if we called super.run, I think it would be a no-op. If we called super.start, that might do something really bizarre. That might blow up our machine, I'm not sure. I'd have to think about that. But it's not like a JPanel where, it's got methods that we might want to get to, like paint, methods that we're overriding. Really, in a thread class extension, the only method we're overriding is run. And there's no reason we'd want to call the original class's run method, because I think it's a no-op. So you probably wouldn't end up using super. On the other hand, the keyword this does come into play, and some people found this in PA5. You might want your thread to be able to access something in the class that's constructing the thread. So you could pass the this keyword to a method or possibly to the constructor, and the thread could use that to save a reference to the object that constructed the thread. Now you can get to things in a different class. For example, the player names in a JFrame, so that the thread could update them or something. And more generally, sharing data among threads. Well, when you make a thread, you can pass information to it, right? I could pass an array to a method in this thread and have it store a reference to it, and my thread could update elements in an array in a different object. And this gets tricky because sometimes we have multiple threads accessing the same object, and that can get us into synchronization issues. So yeah.
How would you actually share data between threads besides showing us about print writer and scanner for PA5?
Exactly the same way. So I could do something like, here's some class that I'm in, and I could do something like, my thread T equals new my thread, and I could say, T.start. And let's say in here I've got, some array of data. Or let's just say I've got some rectangle R. And I want this thread to be able to interact with this rectangle R. Right? So all I have to do, so let's make this my thread class. Let's do class MT extends thread. And here's my run method.
Can't see any of what you're writing.
I'm on the wrong screen. Thank you. So here's my main class. I've got a rectangle R that I've constructed or done something with. I'm constructing a main thread, calling it T, and then I'm going to start my main thread. So MT is a class that extends thread. It's got a run method, and maybe this run method, do something. Wants to do something with this rectangle. Well, this rectangle is part of this class, and this run method is part of that class, right? So how can it get to it? Well, one thing I could do is before I start my thread, I could say T.save R, and I could pass the rectangle to it. And in here, I could say, public void save R, which is a method that's going to take a rectangle argument. And in here, I could just say R equals argument. And I could declare a rectangle named R. So how does this link together, right? Over here I've got a rectangle named R, but it's null to begin with. Over here I've got the actual rectangle that I've constructed and that I want my thread to work with. I construct the thread, and now I call the thread save R method. I pass the rectangle to it. Down here in this method, it takes the rectangle, sets R equal to that. So now this rectangle R refers to this rectangle R. And so now when I say start the thread, the run method starts executing, and I could, change the dimensions of R or print out its area or do whatever I want. And if something over here changes the dimensions of R, and this is continually printing out the area, it'll print out the new area when R's width or height changes.
Question.
So that's, yeah, go ahead.
So I think in PA5, when we do main, we were trying to do like this dot main equals main kind of idea.
Mm-hmm.
If I were to refer to the main, refer to main and change its variable, would it actually update the variable, or?
Yeah.
Because I think I remember doing that, but it didn't work. Because I thought assigning the rectangle, like for example, your example, the rectangle. I thought if I were to change something in R, I thought R should be a copy of R rather than reference to R.
So let's try this. Suppose I say T.save parent and I pass this. And suppose somewhere in here I've got, so let's just call this class main. So somewhere over here I'm going to have an object of type main called parent. And so here's my save parent. It's a method. It takes an argument of type main. And I'm just going to say parent equals arg. Alright, so this is similar to save r, right? When I say save parent, I'm going to call this method. I'm passing this, which is, the object that this is being run from. And so that object is what arg is. And when I say parent equals arg, parent is referring to the same object that this refers to over here, which is, this object. And so inside here, if I say something like, parent dot, so let me get rid of all of this stuff. If I say something like parent dot r, this is the thing that I'm referring to, right? Parent is a reference to this object. I don't get a second copy of this where it copies things over, right? It's just a reference. And if after I've done this I change the dimensions of r and then I look at parent.r, I'll see those new dimensions.
I see, thanks.
Yeah. Alright, so we can share information between threads, and this gets into this notion of synchronization, where perhaps two things might be sharing an object in a way that is what we say not thread safe. And this was this whole notion of read, modify, write. And so we saw some examples of what can go wrong with this, but one example might be I don't know, like a linked list. We've used this before, but it's still a good example. Suppose one method is deleting an element from a linked list, and another method is trying to add something to a linked list. Well, thread 1 is saying delete 20, and thread 2 is saying insert 25. So thread 1 is going to look for the 20 node. It's going to say, here's a 10. That's not what I want to delete. Here's a 20. That's what I want to delete. At that moment, thread 2 has been trying to insert 25. It looked at a 10, it looked at a 20, it looked at a 30. It said, oh, I should insert right before here. What's the node right before? It's a 20. So it said previous equals 20. And at this point, this finishes its delete operation. It gets rid of this, and it changes 10 to point to 30. And now thread 2 continues, and it says, oh, okay, let's take that 20 node and point to 25, and let's take 25 and point to 30. And this is what our linked list looks like now. Our list goes from 10 to 30 to 40. There is a 25 in memory, but there's nothing referencing it, because thread 2 added 25 after 20, while thread 1 was in the process of deleting 20. And the problem occurred because two threads were operating on the same data, and these operations are not things that can be done independently. So ideally, before thread 2 decided to say, okay, let's go ahead and find where this should go and change the previous node to point to this new node, it should get some kind of exclusive access to this list. And if thread 1 starts running before thread 2, before it marches through and finds this node and changes the previous node to point here, it should get exclusive access to this list. So if thread 1 begins and now thread 2 wants to insert 25, this will block. And thread 1 will continue, it'll take the 20, remove it, change the 10 to the 30, and then it will unblock, and now thread 2 can continue and it'll say, okay, there's a 10, there's a 30, oh, we should go right before that. We'll change the 10 to point to a 25, and the 25 to a 30, and everything's great. So sometimes we need to synchronize operations. And in Java, we can do that with a synchronized keyword. I I won't ask you to write code using synchronized, but I might ask you, you might see code with that keyword in there, and I'd like you to know what it does, which it gives exclusive access to one thread, and conceptual notions here. Why do we synchronize? Because sometimes, having two things do a read, modify, write at the same time can cause data corruption. And so we're artificially making these operations atomic. We're saying once you begin the process of deleting a node, nothing else will interfere with you until you're done. So this is a huge read, modify, write operation. It's like do a bunch of reading and a bunch of modification and a bunch of writing. We can make that whole thing atomic relative to, say, inserting. So this will start and finish before something else starts. So this gets into more generally ideas of like deadlock and live lock and starvation and dining philosophers and all that. Again, mostly conceptual questions around that. So deadlock, you have two processes waiting for a shared resource, and neither process can get to it until the other process makes some progress. So I've got the chalk and you've got the eraser. Right? And I'm not going to give you the chalk until I write what I want to write, but first the board has to be cleared. And you're not going to erase the board until you have the chalk. And it's a deadlock. We'll just stand there forever. And then live lock might be, we try to get a hold of the resources we need. We can't, so we put them down and we try again. And I keep picking up the chalk and you keep picking up the eraser. And then maybe we put them down, and next time I pick up the eraser and you pick up the chalk, and we still can't get past that point in our algorithms.
Like it's kind of like go through an infinite loop of basically like an infinite loop instead of waiting, right?
Yeah. So it's the philosophers who keep putting down their chopsticks and trying to run their algorithm further, and the same thing just keeps happening. All right, and then the last major topic we went through was networking. So we talked about client-server models, and servers usually exist first, and clients connect to them. They identify the server with, for us, a pair of addresses, an IP address or a host name, as well as a port number, which says what particular server are you trying to get to. 1, 2, 3, 4 is NetDots, right? 25 is the mail program, and so on. So for Java, we have two types of sockets, a server socket and a socket. And you use those to, set up connection in PA5. On the server socket side, you specify an address when you create the server socket, and then you say accept. And that will wait for a connection request, return a socket, and the socket that it returns will be connected to the socket that connected to that server socket. I don't think I could say socket more times. And there's lots of potential for exceptions in there, so we use lots of try-catch. And for us, we created print writers and scanners to write to sockets and read from sockets. We used flush when we wrote to a socket to make sure output actually got sent through, and so on. And NetDot was an example of a client-server model, but it's a general model where you have a server sitting at a particular port and clients can connect. And in our version, we had one server and one client would connect, and when things were done, both of those went away. But we could also have a more general server that could accept multiple connections, and each time a client connects, it creates maybe a new thread with a new socket to talk to that client, and the main server continues listening for more connections. And so this would be something like an SSH server where, multiple people can log into the Linux machine by talking to the same server, the server at port 22 in that case, because once they talk to the server creates a new process to carry on the business of logging in and running an interactive session. And so that's a more general client-server model. I think that's it for topics. We talked about the URL class, but that was a really fast thing. scroll panes and edit panes. I'm not going to ask you about those. I'm not going to ask you about Android development. So what can I ask you? I can ask you to write some code, which might be similar to things you've done in the programming assignments, or things that we've talked about. But, probably not, something with a great amount of complexity. The kinds of programming questions I ask, right? They might take a long time, but they're not usually things that need 50 lines of code. Sometimes I'm just going to ask for a snippet of code. Like, show me, a few lines of Java that would open a file for output and would also, catch errors and something like that. Or I might ask you to write a method to do something, or I might ask you to construct a class that will do something, or I might ask you to show me, a runnable program, something with a main method in it that processes command line arguments, or reads from standard in, or, reads my mind, or something.
Or you could be mean and give us a compile of code and it tell us what it does.
Yeah. I could just give you bytecode and say, decompile this.
Yeah. I know there's probably some people that are specialized in reading bytecode, but I don't know how to do it, and I don't think it's even. I think it's just too much brain work.
I've heard students talk with a mix of awe and shock about Izad's 270 class, and that he apparently can read and write binary pick code without referring to the textbook, which is pretty awesome. So, yeah, basically, writing some code or fragments of code, maybe looking at code and answering questions about it, maybe looking at code and modifying it in some way, adding something or changing something. Those would be the programming questions. If I do section 2 with like short answer and stuff, it might be, one or two sentences of answer, might be fill in the blank, true, false, multiple choice, not sure. I'm going to shoot for pretty close to an hour and 50 minutes, with a little bit of breathing room, but it's always, tricky to sort of find a good length that will challenge people and still allow people, to mostly finish. So, but, nominally you can expect to probably spend most of the whole time, unless you've been doing this stuff in your sleep since you were 6 years old. And then, it might be an easy exam. But yeah, that's about all I got. So, I have office hours tomorrow morning, 2.5 hours. I have an hour on Friday morning. So if you've got questions, if you didn't figure out PA5 or PA4 completely and you want to go over that, we can absolutely do that. I would not bank on a lot of email availability going on because things are getting crazier and crazier at the end of the quarter. So office hours would be the best way to get information. Weekend is probably not going to be very successful. So if I don't see you in office hours, probably next time will be Monday morning for the exam. And I'm giving an exam 8 in the morning till 10, so you definitely won't reach me that morning. But hopefully, I think people here are in good shape. I would go back and review some of the earlier assignments because some of that stuff might be rusty. But, just based on what people have been doing, I think people are in good shape. So I would just do some review, practice writing some of this stuff if it feels rusty. Maybe get some more practice with PA5 if that's, recent and hasn't solidified. And don't stress out too much over it. Bit of review, and don't be trying to cram things into your head Monday morning. That's usually not a good strategy for tests. And it's okay to be confident. Do the things you want to do to help prepare, but I think you can feel like you probably have a pretty good handle on this stuff. So I just want to say thank you for all of your hard work, and particularly, you know, the 4 or 5 of you who have been here every class and who have, you know, been coming in the morning and so on. I really appreciate the effort of that. Um, and some of you I've had, you know, in classes for 2 years or more, sometimes going back to 250 or back to 101. And I've definitely enjoyed working with all of you. So I hope this has left you in a really good place. And I predict good times as you move on from Clark and dig deeper into this stuff wherever your journey is taking you. You know, I think this is always a good place to be, and I hope it's a good experience for everyone. So yeah, thank you, and I'll let you out a whopping 5.5 minutes early for the last class here. And have a great afternoon, great rest of the week and weekend, and I will see you Monday. All right, take care.
Bye bye.
Bye bye. All right, thank you.